Hi there. I think we're ready to start now. And first of all, I would like to warmly welcome everyone here. It's my pleasure to be presenting here today. And well, yesterday we had a number of amazing talks related to how you can build your LLM-powered application and how you can build your RAG system. So today I'm going to continue this conversation, and we are going to discuss how continuous testing can help you to keep your LLMs on track. So that's basically a question for the day after you deployed your model to production, and then you start really caring about how to keep your LLM-powered application on track. My name is Emeli Dral, and I'm CTO at Evidently AI. This is a startup where we build open source tool to evaluate, validate, and monitor machine learning model in production. So basically, previous to that, I helped many companies as the chief data scientist to build and deploy machine learning-based application to production so that they can optimize their technological and business problems. And the way how we build tools, and evidently, is very much inspired by the experience we gained during this years of building machine learning models. So yeah, now let's move to our topic, and we are going to discuss LLM-powered systems. And I would like to split this topic into two big parts because I believe very few of us really train huge large language models from scratch. I mean, it's generally done by companies like Anthropic or Meta or OpenAI, right? And we are not going to talk today how to make sure that the model you train from scratch is good enough. I believe there are quite a lot of things there, like benchmarking and other metrics, security, relevance. But today we are going to more discuss how we can make sure that we build very nice LLM-powered applications. So we are going to evaluate quality of the applications which are powered by large language models. So basically, it's very specific use cases, and we are going to discuss how we can make sure that our scenario work well, taking into account all these specifics. So, well, there are many different ways how you can utilize LLMs nowadays. You can build generative applications, like something for text summarization. I believe everyone already tried to load very huge articles and then just read a small paragraph of what was the idea, right? And there are many applications of generations. Like I personally enjoyed code generations because now I stopped write any Python tests, just LLMs write it to me, and I'm very happy about it. And of course, there are many chatbots and virtual assistants, so we really can build a lot of generative applications with help of LLMs. But actually, nothing prevents us from building non-generative applications with help of LLMs. Because now, if you prefer not to train your own logistic regression or gradient boosting to do topic modeling, you're very welcome, right? Why not to just use LLM to do your classification, search, or data instruction? So for both generative and classic application, we need to do some evaluation. And actually, we need it all the way we work with our application. I believe it's very important for pre-production stage, where we do quite a lot of experiments. For instance, we experiment with different prompts or chain of prompts, right? And stress testing, of course, for check whether our model robust or not against some adversarial attacks. And of course, as soon as we deploy our application, we need to do some monitoring, so we need to continuously analyze the quality of our model. And also we can do some regression testing to make sure that after we change our prompt to fix the issue with one test scenario, we do not break actually all the rest, right? This is why regression testing is also important. And for many critical cases, we also need to have guardrails because, well, sometimes we just want our model to not answer anything at all, like not to give any financial or medical or legal advice. This is why guardrails is also a big part of the production evaluations. But, well, our time for today is limited, so we need to focus on something. And we choose to focus on online evaluations, which is basically monitoring and regression testing, because I believe this is a very good start of what you can do as soon as you deploy your LLM-based application to production. And well, when it comes to monitoring and regression testing, one can say, actually, we have production models for ages. Why cannot we just not to apply standard software monitoring to LLM-powered applications and that's it? And I would say, yes, of course we can do that. It's a very good start, but there are some specifics related to LLM systems. First of all, there are quite a lot of things which can go wrong with LLM-based applications. And first, and very straightforward, is actually low quality responses, where basically our responses can have wrong tone of voice, which is not appropriate to what we like in our organization, right? It can be too short, too long, or maybe it's just wrong advice, right? We really need to measure it and be able to prevent this from happening. Also, quite often we design specific user scenarios, but after we deploy our application, we suddenly see that users actually started to develop new scenarios, ask our application about new things, and this is so-called data shift, right? And it does not necessarily mean that our LLM will break after it see the first new scenario, but it can be a very nice signal to like check whether our application can help with these new scenarios. And of course, there are quite a lot of things which can happen with LLM in generally, like some model attacks where someone like injects something into the query and it distorts the output, right? Some hallucinations when the model tries to create new unexisting things. And of course, if you rely onto like just the latest version of some third-party model, which makes total sense because we know that each new version is better and better in terms of training on the new fresh batches of data. But if you really rely on the latest version, the behavior can change, and it also makes sense to like test whether it breaks or not your new scenarios. So there are quite many things which can happen, and well, why it's hard to do LLM evaluations? Basically, I believe there are three main issues we need to address. And the first is there are many correct answers, because when it comes to traditional supervised learning, in general, we can quite easily check the quality of our models. For instance, if you do churn prediction, or maybe you do some demand forecasting, you just do your prediction, then you wait until you get your ground truth, your right labels, then you compare what model predicted to the right labels, and that's it, right? So it's pretty straightforward. But when it comes to generative application, you cannot really compare your output with the ideal answer symbol by symbol because, well, it just doesn't make sense, right, from the logical point of view. There can be different symbols, but the text could be quite good, right? Or they can be very similar, but because of like small not sentence, it can be like totally different in terms of sense. This is why it's quite challenging to build right system to check the quality. Second is we don't really build a lot of very generic applications. In most cases, it's very specific, and this is why we have very subjective quality criteria. Like we prefer to have very helpful answers, right? Or maybe we prefer to, well, definitely we prefer to, if we do code generation, we need to have the working code, right? Or maybe the right tone of voice, the right professionalism. And it's quite hard to implement the evaluation which does this subjective criteria automatically. So we need to do something. And the most straightforward way would be, why not to just hire someone for evaluations, like, I mean, some experts or analysts, but unfortunately it doesn't scale. So we can do some labeling with help of human experts, but we cannot really ask anyone to like evaluate all our data, especially if you have like pretty good scale. I mean, if it's very popular application. So yeah, that's quite interesting how we can overcome such difficulties for LLM evaluation. And I believe if we can formulate it as a goal, it could be something as follows, right? We need to somehow automate evaluations for open-ended text data using very task-specific criteria. And now we are going to discuss how we can do that. So let me move to the next topic, which is data, because always when we talk about evaluations, we start from the data, right? And here, for LLM-powered applications, we also could have some data in offline, I mean some historical data which we already store, and some data which we can access during the application usage, like in near real time or real time. We will always have some input data and generated output, right? It does not necessarily need to be text, it can be images, audio, video, whatever, but we have some input and output. And what is the difference, the main difference between the offline and online? In offline, we might have some correct answers or at least some references, right? And this is very nice because we can build our evaluation based on the comparison between what is known good answer and what we got from our LLM. But when it comes to online, unfortunately, no true labels. Like almost always. We need to wait and label, and only after that we have these labels. We might have some context, especially if we do RAG application, but nothing more. So having this data at hand, let us think through what we can do to prepare our data to be used for evaluations. And when it comes to offline evaluations, I believe the best what we can do is to collect some test cases. So it could be some test cases which can be synthetic data, which you just assume to be a good example of how the users should use your application. Or you can just log into your application and start to use it and then use your usage data as the test interactions, right? Because you probably understand what are the good scenarios of using your application. And of course, if you already deployed your application, you just can collect and cherry pick some user sessions. So this will be your test cases. And then it's good to do some labeling, and there are also several ways how you can do that. So you can either label it yourself if you're a manager or analyst. So unfortunately, you have to, right? So that can be first way how you can label data. You can also outsource it to some users, or maybe do some LLM labeling, which is quite tricky, because if you do LLM labeling, you might still need some review, but that's also an option. And the ultimate goal here is to create so-called golden data set, which will include some test cases for your critical path, the typical user requests, maybe some corner cases, and some adversarial scenarios as well. If you prefer to split it into several data sets, it's perfectly fine. It can be like this, but the idea is that you can grow continuously your golden data set, and after every time you do any changes to your prompts or chain of prompts, you can run this regression tests on top of your golden data set to see whether you break something while you was fixing something, right? So that's the idea. And of course, you cannot build this data set in 15 minutes. Well, maybe someone can, but generally it's quite time consuming. So it's okay to iterate on this golden data set and add new test scenarios gradually in time. So you break something, you say, nice case, just add it to your data set, and it works pretty nicely. So that's for offline evaluation. When we move to online evaluations, the idea here is actually log everything you can. Not literally, because if you do tracing, it's quite huge, right? I mean, every trace might include quite a lot of events and interactions, so it's important to be mindful here, but the idea is to try to log everything you can to be able to complete your assessment for every event and session. It might be user input, system prompt, system response. If you call some external tools, like maybe tool to add event in your calendar, or maybe tool to create a note or something, you can log this as well. And of course, user actions like upvotes, downvotes, everything user did with your LLM application. And together with online, I mean real-time or near real-time evaluations, you of course can do evaluations in batch, which is also perfectly fine. So if you prefer not to keep it in real time, that's also okay. Well, that's our data. For online, we try to do logging and tracing. For batch, for offline, we try to do some golden data set. Now the most interesting part, I believe, evaluation scenarios. And to be fair, we have so many because the applications we build are very, very different, right? And sometimes we have labels, sometimes we do not have labels. We can use RAG or not. So I'm going to share with you quite a lot of scenarios, not to just overwhelm you with the information, but maybe rather to inspire you to choose what suits to your application the best, and then start to iterate on your evaluation process. So let's start from something pretty simple. If you're lucky enough to use non-generative application, where you do some, for instance, user intent classification for a chatbot, like where is the invoice? Oh, that's a question about billing, so that's classification problem. In this case, you can continue to use pretty traditional ways to measure the quality of your application. So if it's classification, then use classification metrics like precision, recall. For ranking, again, mean reciprocal rank, hit rate, NDCG, whatever, so we can keep it pretty traditional here. So the regression testing would be as follows. As soon as you change your prompt or anything in the chain of your prompts to solve your classification or ranking better, you just run regression testing on top of your new model, updated one, and you compare the quality of classification between the previous version and new version. So pretty standard, very similar to what we did before when we just compared different algorithms to do classification, right? So here we keep the same idea. Moving on, if there are many good answers, and here I'm talking mostly about the generative applications, here we already cannot do just comparison-based evaluations, right? For instance, in this case, we try to answer to the user question on where is the invoice, and we cannot really just calculate the precision, right? We can go for semantic similarity, maybe some overlap-based metrics like blue on rouge. I'm not a big fan, but why not too? You can use some LLM as a judge approach and many other things which does not really rely on the right labels. And let me be more specific here. Just imagine you have reference answers which are known to be good answers because you labeled it manually or maybe did it with help of some human experts. So you have some reference answers which are known to be good. Then you generated some new answers with help of your updated prompt, for instance, right? And what you can do here is just try to do pairwise comparison and calculate semantic similarity between each pair of answers. This is a very interesting idea because you do not need to compare this data symbol by symbol, but you can just implement the semantic similarity measurement metric, which will varies from 0 to 1 or from -1 to 1 if you like assign similarity. That doesn't really matter here, but it will allow you to be very specific in comparing the semantics of two answers, which is quite a good idea. Then after you calculated this semantic similarity for each pair of answers, you can calculate the statistics on top of it and then do some regression testing on top of calculated statistics. Like, for instance, first you calculated the semantic similarity, then you calculated the mean value of semantic similarity for your data set, and you test again the minimum value or mean value or maybe something else like median. So this is a very nice approach to compare your models and say whether your new experiment is better or worse. At least it works for the golden data set you created. And here be mindful, because if you created bad golden data set, then unfortunately it doesn't really help, right? This is why it's important to iterate on your golden data set. Well, let's move on. Sometimes we build the RAG-based application when our answer relies on the retrieved context, right? So for different contexts, it would be different answers. Here you can use more evaluation methods like LLM as a judge, where we can try to check whether our response was relevant to a question or not, or was the response grounded. I mean, it really depends on the context. Let me draw some examples here. Just imagine you want to implement LLM-based evaluation for your LLM. I mean, basically use LLM as a judge approach for hallucination detection. This is a very interesting approach, I believe, because what you can do is you can use the other LLM to judge the output of the first one, but you can pass the response, which was generated by your application together with context, and write a prompt to check whether the response has a statements not presented in the context. Basically, application invented something which was not in the context before. Or you can try to check and ask LLM whether the response follows from the context. This is also an option, but yeah, it takes you to write pretty nice prompt to actually check that from LLM. But such kind of comparison can return to you true and false, and then you can just calculate the share of truth, right, and see how good your new prompt is. And actually for hallucination detections, you can use different approaches. It might be LLM as a judge, but you also can go for semantic similarity here, because here we have a very nice example, I believe, when user asked how I can change my password, and our application answered that to change your password, just click on your profile, select security, and choose change password. Looks pretty logical, right? But we have some context derived from the our database, where is the instruction to resend your password, go to the login page, click forgot password, and follow the email instructions. So definitely the instructions are quite different. And of course, you can ask LLM whether the response actually follows from the context, and I believe it will say no. Or you can go for semantic similarity and just calculate the distance between the response and context, and it should be pretty big distance, right? And the reason I bring it up here is that actually it will be for free. I mean, for using LLM as a judge, you need to pay for every API call, but if you go for semantic similarity, it's for free, so why not do that if it makes sense for your application. So it's always like an art to build very nice evaluations for LLMs, but I believe it's very interesting. So yeah, going back to LLM as a judge, you can then test in regression testing. You can check for like share of category false, and then manually review all the responses where you had this label false. Why not to add to your golden dataset such examples? I think it makes sense, because later you will be able to do regression testing taking into account such kind of examples, which is quite good. So now moving on to other options. If you cannot really create the quality metric, but you know what is the positive criteria, which kind of says that this response is likely good, then you can go and build your evaluation on top of these positive criteria. For instance, it can be criteria that the good answer should be something between like 50 and 100 words. Or like generated code should work. Actually, this is pretty obvious, right? Or response should follow the defined structure, like start from hello and say thank you at the end. Maybe tone of voice or response should be in French or English or Dutch, right? So there are quite a lot of rules we can assume as the good signals or positive criteria. And when it comes to evaluation methods, we can do quite a lot of things there, because it can be, for instance, some functions. If we have a sandbox, we can try to run the generated code and check whether it works or not, right? Or maybe you can do some model-based evaluations, because there are so many ready-made classifiers and regression models, for instance, in Hugging Face, which can do for you toxicity analysis, PII scoring, it's personal identifiable information. They can do for your sentiment, and it's actually a very nice idea to use it as the validation for your responses. Why not to share the mean sentiment of your responses? This is a good measure, and if you load this model from Hugging Face, you actually do not like pay for every API call. I don't know why I'm so focused on payments today, but just trying to be like financially effective. Let's call it like this. Well, how it will be looking like? You have your response, then you check for every single response what is the sentiment, and if you prefer, you can definitely train your own model, or you can load one from Hugging Face, for instance, and then you just get a score for every single text. Then you calculate statistics. We like statistics. This is the example from Evidently. And then you can write a test based on some mean value or minimum value or median value, which is very nice. I always bring up the testing because I think it's important to like think how you're going to automate this. And if you do regression testing, it's always good to think about not only about metrics, but also how you can transform this metric, this measurement to a test. Like, okay, it's good to be able to measure sentiment, but then I will need to calculate some statistics and come up with the test with condition. So this is why I believe tests are important here. So yeah, if you have positive criteria, we definitely have some negative criteria, right? And here we can use pretty similar things. So we can do some toxicity detection or PII detection, or maybe check for something very case specific, like maybe this response is not actionable, right? Sometimes it's actually not good. Or maybe this response is too positive or too negative. Well, this all might be very case specific, and you can implement it with the respect to your application. And here you can use so many different methods, like even regular expression. I know that it might sound too simple for LLM evaluations, but it really works. I'm going to show you a couple of examples, like in the next slides. You can use statistics, like, well, if my answer is longer than X, then nobody's going to read it till the end, right? Or maybe some classifiers again, but now not like sentiment, but PII detection. Semantic similarity, of course, if you know some negative examples, you can compare the distance or similarity between your good example and known bad example, right? So there are a lot of ways how you can do that. And I would like to share first the using of classifiers like PII, it's personal identifiable information detection or toxicity, because it's pretty general models which you can load and use already pre-trained, so it will be very fast to do that. And actually, you can even use very simple regular expressions. Just imagine you have a virtual assistant which is supposed to help your customers to browse your catalog and find the best products. And it will be pretty shame if your user asks something from your virtual assistant and it suggests to buy it from your competitor. Not really nice, right? And this is why you can create a regular expression which just check whether your application mentioned any competitors. It's very straightforward regular expression, and then you just calculate the how many times it happened, preferably never, and then you can analyze each case when it happened. So regular expression, old good thing, but still works very nice and very fast. Well, also, of course, you can use LLM as a judge if your negative criteria are quite complex and you cannot really create a regular expression for that. But here, just be mindful, because here prompt matters a lot, right? And we do not want to have like another evaluation system which evaluates our prompt, which we created to evaluate our application, right? So this is why I believe there are quite nice heuristics to share, like try to keep it simple, maybe binary or categorical, so that the LLM return to you some binary values, or maybe categorical, right? Include in your prompt some good and bad examples. It's really increase the quality of the answer. And do not ask LLM to do an expert work. Just imagine that when you write a prompt, imagine that you talk to an intern and you need to like describe everything. It really helps. So yeah, you can do that. And actually, what is also interesting when it comes to LLM judgment, LLM is a judge, you can send individual events to the LLM, or you can do it by sessions. So you can create the whole session and send it to LLM to treat whether this session completed successfully or not, right? It's really hard to do it like with help of regular expression, but when you pass the session to LLM and ask, was the user happy at the end? Was the problem solved or not? It's quite possible. So yeah. Now let's move on to some proxy metrics, because I believe it's also very interesting. Quite often we can have some proxy signals collected in our system, like after user interacted with your virtual assistant, it can upvote or downvote the response, right? And it's actually also a very nice signal. So you can just calculate the share of upvotes and downvotes and do your measurement based on this. Not really fancy, but why not too, right? And also there are quite a lot of proxy metrics like session length, the share of abandoned session, or time spent with the agent. So it's also a good metrics, especially for product and business analysts who are responsible for like increasing the quality of your application. Also, if you're lucky enough and you have some previous iterations of your model, so you know what is the normal or good production baseline, you can compare your current system with the previous one, which is also a very nice approach. In this case, you can go for some data drift, and it can be data drift. And if you're lucky enough to have the previous good baseline, you can build your evaluation based on the comparison between your new system, new application, and the previous one. How you can do that? Just compare output of your new model with the output of your previous model. And if we're talking about text, which is quite a general case for large language models, we can even try to like train a binary classification model, which will try to differentiate between the outputs of your previous model, like previous version of prompt, to your current version of prompt. Then we can use something like logistic regression. It's quite fast, and we can use the bag-of-words model for text representation. And if we do that, and we can see that our binary classification are able to distinguish between the previous version of prompt's output and the current one, we can even go deeper and debug what was the most important features. In our case, if we used bag of words, it would be words, and we can figure out what exactly has changed, right? Like in this example, the sentiment has changed, and we can see that the characteristic words were love this romper, nice top, beautiful, and now it's so filmy, really poor quality, so the difference is the sentiment, right? And this is what you can achieve for free if you build a binary classification model on top of bag of words. So this can be also a pretty nice way how you can compare your new model to your previous baseline. At least it will help you to generate some hypothesis of what has changed. So yeah. Last scenario I would like to show is the scenario when you want to build something like a product analytics and understand your users better. It might be also very useful for debugging, and you can do it in online monitoring. Here I believe that you can build quite a lot of models like topic modeling systems or clustering systems to understand what is the topics of user requests. Like for instance, you can do it in a batch mode, like aggregate the queries for the whole day, or maybe in hour basis, right? And do some topic modeling. Then you can do it like with some moving window and see what topics were requested by the users. And suddenly you can see that, well, there is a new topic generated or new 2 topics generated, and try to check whether your model is able to respond to those topics correctly. So yeah, there are quite a lot of things which you can measure for your LLM, starting from something really simple like regular expression to using LLM as a judge. So let me quickly recap what we have discussed, because it was so many things. And well, there are so many methods for LLM applications. Evaluations. You can start from some text statistics, like just length of your response or the amount of out-of-vocabulary words, right? Something like this. Then you can go for semantic similarity, especially if you work with the generative applications. Like you can compare new answers to old. You can compare the response to context, right? Or response to requests, so be creative here. We can do some regular expressions. We can use some already made models from Hugging Face. We can do some LLM as a judge. So it's very important to be very specific and build up the evaluation systems that does not just exist, right, but helps you to debug your application and understand whether it's good enough for your specific case. Well, how to do that? There are quite a lot of ways. You can actually implement it using any programming language of your choice, like for instance Python or maybe JavaScript, whatever you use. So you can just implement those evaluations and run them on schedule, or try to use some ready-made tools like Evidently, and I'm a maintainer. So I really invite you to take a look at our repository, because we have so many descriptors and so many evaluations. Like here you can see that it's quite short. You just generate the report and say, I want to build my text evaluation for column questions. I want to check contents of brand 1 and brand 2, sentiment, text landed. It's quite simple. And you get this visualizations with statistics automatically. So to sum up, for offline, I would suggest you go for regression testing, because every time you change something in prompt, you definitely want to check how it influences on the whole test cases, which you included into your golden data set, so you can rerun evaluations after every major update. And well, set some realistic expectations, like these thresholds should be necessary, like I have 0 negative responses, maybe less than 10%, something like this. And for production, do monitoring, right? So define a few custom quality metrics, and I really, really believe in custom metrics, because nowadays there are not many like toxic models or models which returns you negative responses. There are not many of them, but it can be not really helpful, right? This is why it's important to come up with your custom quality metrics. Collect some simple statistics. If you prefer to do it in a batch mode, do it in a batch mode. No need to be real time in 100% cases. And yeah, it's always good to have some raw data to debug, so that you can update your golden data set and maybe even debug and fix some issues with your model. Basically, that's it. That's all I wanted to share with you. I'm happy to answer any questions and discuss anything you like. Thank you so much.
Hi, thanks for the talk. To come back to this golden data set example, so you have a prompt, you have a candidate model, and you have a response which you compare to a golden answer. What do you do with temperature in this case? So do you set this to 0 to always get the same result and to compare that, or do you set it to some high number and run it many times and compare it to some distribution? So what's your advice there? Thanks.
Oh, that's a brilliant example. Let me quickly bring up the picture. Yeah, so for golden set, your your reference is already created, right? Because you compare the new answers with the reference. And when it comes to the reference, I would rather derive it from the model with the temperature parameter you use in production. I mean, it makes sense from the point of view that actually you want to compare your prompt as it is and make sure that it's going to generate nice values in production. So if you keep the temperature equal to 0 in production, then keep it equal to 0. If not, I would keep it higher, but in this case, maybe do something like cross-validation. So generate like 5 answers, then compare something like semantic similarity and take the mean value. Yeah, cool.
Hi, thank you for the talk. It was very interesting. It seems to me that now the industry has taken the approach of using LLM as a judge, and I can understand it for scalability purposes. Now, in your experience, how skeptical do you think we should be about those metrics? Because we're asking a tool that could hallucinate to measure hallucinations as well.
Yeah. Yeah, I like this question. Thank you so much. Well, yes, I believe it can be like a chain of validations when you need to validate your prompt, which you use to judge your initial applications, right? And I wouldn't be too skeptical here. I think we should be very pragmatic by using LLM as a judge. I mean, for many scenarios, it's just not needed because it's a very general approach and you can use like ready-made models. But if you do really have very complex scenario where you want to use LLM as a judge, I think the human expert validation is very important here. And I would even do it like continuously, so maybe derive 1 or 2 judgments from this model to like check manually that it still gives you good quality. But I'm really worried here about the cost of the validation because you anyway have to pay for each call for this third-party model, and then if you have like 5 judges or 10 judges, I believe it's kind of ridiculous, right? You pay more for evaluation than for the application itself. So for me personally, and I'm not enlisting here, it would be like last resort judgment if I have like no other options. And of course, human experts are even more expensive, then I would go for LLM as a judge. Again, I think it's a good approach, but it's quite time consuming to like create this prompt and make sure you like it, and you still need to validate it. And when it comes to regular expression, you wrote it once and that's it, it works for you.
Hi there. I wonder if you know anything about or have considered any kind of red team approaches where you have something external to the system actively trying to break it and effectively testing the tester?
Well, can I ask you to repeat the last half of the question? Because
Yeah, so just like the idea of like testing the tester. So you effectively got a set of techniques here for trying to see if the LLMs are producing bad outcomes, but have you considered testing those methods by getting something external to actively try to make the LLM do bad things and then use that as an evaluation of the evaluation method kind of thing?
yeah, that's a great question. I like it a lot. I think it can be done with help of the same golden data set because it's really hard to say whether your testers work fine or not if you did not check the quality of testers itself. And I think here we can split the evaluation method into 2 groups. First are like statistic-based and regular expression-based. Here I believe we just do not need this testing by design, right? But when it comes to using models as a judge or LLMs as a judge, it's always very important to have this validation data set. And basically, it's something very similar to what we do in traditional machine learning, like when we have a validation data set, and prior to deploying the model to production, we check that we are happy with the precision and recall and whatever metric quality level. I believe it can be done pretty similarly here with testers. So before you really rely on the quality of your testers, you check on top of historical data, and this is pretty critical moment because we not always have enough historical data to make sure that we really can trust these testers or not. So what I would do here, I would try to collect as fast as possible, maybe even using some synthetic data, critical examples, like this is my critical example. I gave the legal advice. I need to make sure that my testers catch it. And if it doesn't catch it, so just do not trust them. And then later, when you collect more historical data, you can label all the issues you want to catch with help of your testers. And every time you update your testers, you run it on top of this labeled historical data and check whether it was able to catch the previous issues. If it was able to catch it, cool. If not, update. Thank you. Yeah. Thank you so much.